Hey everybody, welcome to 2.6. We're going to talk about applications of exponential functions. I got a little bit of a different thing that's going to happen today. I don't have my little tablet I write on because I'm having to work from home. And it's going to take me a little bit longer to type these equations in, so just bear with me. And we'll go ahead and get started. So let me get to the notes. All right, so I've prepared right many notes here. This is 2.6. It's got a lot of formulas. Now these particular formulas here, I call them basic exponential growth and decay. These are really your math 1 formulas. Okay, so you got to find your rate as a decimal, subtract it from 1, that gives you a decay. Because remember, if this amount that's being raised to the power of t is less than 1, it's decay. If it's greater than 1, it's by definition growth. Okay. All right, and we're just going to work these out as we go along here. And what I said might take more time is I'm going to have to type them in to the Google Doc, and that is going to be a little slower than normal. Okay, so here we go. Let's just read this first and decide which type we have. This is going to be a basic one. All right, so example 1 says an element with a mass of 320 grams decays by 5.1% per minute. To the nearest tenth of a minute, how long will it be until there are 200 grams of the element remaining? Okay, so what makes this a math 3 question, not a math 1? Is it's asking how long, not how much. So we're going to be solving for t on whatever formula we're using here. And it's going to be decay because we're literally saying it right here. It's decay. And let's see what we can do with this. Let's write the formula out that we have. And let's fill in everything we've got. So we'll insert an equation here. Right, so we know that the one we need is a of t is equal to the mass was 320. That's your initial amount. These formulas need to be updated, you guys. They need something there. Initial amount, right? Times 320 times 1 minus, your rate is 5.1, but we're going to have to go 0.51. Always move that decimal. And it's raised to the t power. Okay, so we're going to be solving this for t. Now, really what we do know here is that, let me get some more space. I'm going to come up here and talk about this. The amount they want to know how long it gets to is actually 200 grams. Now, so it's decaying. So it's going to go from 300 to 200. We want to know how long. So we need to plug that 200 in for the amount. Okay, and we'll write another equation for that. So we would have 200 equals 320 times 1 minus, when you subtract those two numbers right there to make it a little simpler, you can perform that calculation. You get 0.949. And that's going to be raised to the t, and we're going to solve this for t. Okay, so the very first move you'd have to do is isolating the exponential expression. You'd have to divide both sides by 320, right? And when you do that, I'm going to write it again down here. You get, so we're going to divide both sides by 320, reduce the fraction, or leave it as a decimal. We get 0.625. Okay, let's divide both sides by 320, and now we have an isolated exponential expression, and that's what we needed. So the next move, not to the 6, to the t. And the next move is to take the log of both sides. Doesn't matter which one, but use a convenient form. You can use natural log or log because your calculator will make that computation easier because it has those built in as functions where you don't have to change the base or anything. Okay, so I'm going to take log of 0.625, and that's going to be equal to log of 0.949 raised to the t. And what's going to happen is now that you have this equation, this t can be moved out front by one of your third law of logarithms, right? So essentially, so I don't have to write it another time. Well, I'll tell you what, I will do that. Let's do that, just so everybody can see it in this one. Now, we'll start skipping that step in a minute, so the videos won't have to be so long. Oh, you know, I should have copied that and pasted it. I gotta be smart here. And that what's gonna happen here is that t essentially in your next move moves into the front of that, not right there, to the front of your logarithm. All right, that's that property we talked about. Now we can divide both sides by log of 0.949, and that is going to be isolated. Right, so the final calculation here, I guess we should have put an equal sign there. We'll go down here and say, okay, finally t equals, make that a fraction, and it's going to be log of 0.625 divided by, don't do that, log of 0.949. And you don't need that asterisk there. I apologize for this video having to be done this way, because I think the other tool works a lot better. But I have to talk about it as we go, and sometimes I might just sound a little silly. And this is approximately, when we work it out, let's see what we get. So we got log of 0.625. Now you see why I use the log, or I could use natural log. Oh, it's going to be divided by 0.949, and it looks like it's going to take about 8.97 years, or minutes, sorry. I think we're in minutes here, aren't we? Yep, about 9 minutes. So we would say, I think some of the problems are asking you to go to the tenths place, and I think this would round up to approximately 9. And there we go. That's what we want, approximately 9 minutes. All right. Okay, I know that's a simple one, and I know the formatting took a while, but it did create some pretty good notes for us. And I'll highlight these, and we'll move on to more complicated stuff in a minute here. You should watch these videos before you attempt the problems if you've already had to start, understand that. And I will see you in the next one.